All right, let's jump right in. We're going to talk about a single secret rule of the universe. A rule so fundamental, it literally builds reality itself, from the color of a flower all the way to the thoughts inside your head. This is quantum theory, but not like you've heard it before.
So, take a look at this butterfly. It's beautiful, right? It's intricate, and it has a very specific size. But here's the wild part. The physics of Galileo and Newton, the rules that describe throwing a ball or planets orbiting the sun, has absolutely no way to explain why this butterfly is this big. Why isn't it the size of a mountain or an atom? There's just nothing in those old rules to set the scale for things.
And it gets even weirder. Think about the glow of a firefly, that light it creates, its specific color and its brightness. That's another complete mystery for classical physics. It's like all the rules we think we know about the world just fall apart when you look closely at some of its most basic, beautiful features.
And that really brings us to the core question here. How can the rules that seem to work so perfectly for our everyday lives be so completely wrong when it comes to explaining the very fabric of the world we live in? What are we missing?
Well, the reason is that classical physics, for all its genius, has a huge, fundamental flaw. It's an incomplete story. It's missing what turns out to be the most important piece of the entire puzzle.
And this problem goes deep. You see, the classical world has no built-in ruler to define length and no internal clock to measure time. Without a fundamental scale, it just can't explain why things have the size they do. It can't explain shapes, our senses, or even our emotions, because all of those things depend on specific scales and structures that classical physics just can't create. But then, back in 1899, a physicist named Max Planck kind of stumbled upon the solution. He discovered a single secret rule about how the universe works, a rule about the smallest possible change that can ever happen. And this is it. This is the hero of our story, the quantum of action. It's represented by this symbol, h bar, which we call h bar. Now, forget the math for a second. Just think of it like this. It is the universe's absolute rock-bottom speed limit on change. Nothing in the entire cosmos can happen in a smaller step than this. It's the minimum ticket to ride. And just how small is it? It's ridiculously small. It's a decimal point followed by 33 zeros and then a 1. I mean, it's an unbelievably tiny number, which is exactly why we never, ever notice this rule in our daily lives. The world looks smooth and continuous to us, but that's just an illusion. So the big takeaway here is that nature makes jumps. They're tiny, imperceptible jumps, but they're jumps nonetheless. You literally cannot observe any change, any action smaller than ha. It's a fundamental law of reality. And this one simple fact has the most incredible consequences. Okay, so now let's unpack this. How does this one tiny rule manage to build, well, everything? It's like a domino effect. The existence of this minimum change sets off this amazing cascade of effects that constructs the reality we all know. Get ready, because once you accept this one little rule, the world starts to look a whole lot different, a whole lot weirder. Okay, first consequence. If there's always a minimum amount of change happening, then true absolute stillness is impossible. Everything in the universe, from the atoms in this screen to the atoms in your chair, is constantly buzzing with this tiny, irreducible motion. Nothing is ever truly at rest. And here's the beautiful part. That constant jiggle is what allows things to exist in the first place. Because perfect rest is impossible, particles can't collapse into infinitely tiny points. This constant motion props everything up, giving matter stable structures, definite shapes, and real sizes. Without this rule, atoms couldn't even exist. And remember that firefly we talked about? Well, this rule is the answer. Every single color you have ever seen is a quantum effect. The specific colors of light that an object soaks up or gives off are decided by the size of these quantum jumps happening inside its atoms. So let's just do a quick comparison here. The old classical world we used to imagine was a place of infinite precision and predictable paths, but it had no way to actually build anything. The real quantum world is fundamentally fuzzy, but it's that very fuzziness that gives us the built-in scales needed to create everything, even if it costs us a little bit of perfect predictability. Okay, this idea of fuzziness is probably the weirdest part of this whole story. It means that at its most basic level, reality isn't sharp and definite like we think it is. So let's explore what that actually means.
This fuzziness is actually a law of physics. It's called the Heisenberg indeterminacy relations, and the concept is simpler than it sounds. Because there's a minimum amount of change, you just can't nail down everything about a particle at once. The more precisely you know where it is, the less precisely you can know where it's going, and vice versa. It's like a fundamental trade-off that's baked right into the fabric of reality.
And this is not just some abstract idea. I mean, look at a water molecule. We always draw it with a fixed shape, but in reality, that shape is constantly fluctuating. The atoms are always jiggling around. The shape we talk about is really just an average, an emergent form that's born from all that quantum fuzziness. And think about this for a second. If nothing has a perfectly defined position or energy, then you can't build a perfectly regular oscillator. And what that means is that perfect clocks are physically impossible. The fuzziness of reality even extends to how we measure time itself. And now for the final and, I think, most profound part of all this. All these cosmic mind-bending rules, they're not just for distant stars or tiny particles. They are the rules that build you. This is a direct quote from the material, and it's a powerful one. The chemical reactions in your brain that create your thoughts and your feelings, your happiness, your fear, your love, all of that is governed by the quantum jumps of electrons between molecules. Our very consciousness is rooted in quantum mechanics. So ultimately, what this means is that we are not predictable clockwork machines. That classical idea is just wrong. Life itself, with all its complexity and its richness, is a symphony of quantum effects, all playing out on a massive scale. And that leaves us with one final, fascinating question to just sit with. If the very bedrock of our reality isn't solid and certain, but is instead a world of probabilities and inherent fuzziness, what does that tell us about our own quest for certainty in our lives and in everything we think we know? It's something to think about.